Hi, Bob. So here's a real quick explanation. I think the first part we'll look at is what's boxed here in yellow, is how in the world did they get from this to having this guy inside with this factor outside. So we're really looking at why can these two multiply together to give us this, and that's what's here. Here's our x squared plus 4 to the 1/3. And if you take this x squared plus 4 to the negative 2/3, which is out front, and we look at this x squared plus 4 as having an exponent of just 1, when you add those two together, you get 1/3. And that's what is here, this 1/3. And then here we have no coefficient, but if you take 1/3 times 3, that is multiplied together to be 1. Sorry, not no coefficient, that's a 1. And so you get 1. So they're doing this artificial pulling apart. And the reason why they're algebraically taking this little bunny hop is because they want to factor out of this piece here. And they want to take the 1/3 out front. And to take that 1/3 out front, you need to have a 1/3 from this first term. So to get that 1/3, they did this algebraic. And then to get that negative 2/3 exponent to pull it out front, you want to be able to have that here as well. So that's why they did this little manipulation. So the goal was we're trying to get x squared plus 4 to some exponent out front, because that's what we've got here in the denominator. So we want to be able to simplify in some way, and to do that, you need a factor that's in common to both. And so that's how they're doing that manipulation to get to there. So here's that 1/3, and here's that negative 2/3. Now on the inside, go ahead and multiply these guys out. When you multiply them in as distributing, you get 3x squared plus 12 minus 2x squared, which gives you that numerator. And so our numerator looks great at this point, so that's where this is coming from. The denominator, because this is the negative 2/3, we're going to bring it to the denominator. The exponent gets positive because he moved in the fraction. And then we're going to multiply this times this. X squared plus 4 to the 2/3. Same thing to the 2/3. Add them. 2/3 plus 2/3, which is what you see here. You add them and you get 4/3. And that should be a 4/3 over here. And so we get x squared plus 12 over 3x squared plus 4, all raised to the 4/3. You should know that in my applied calculus for business students, I have them stop way up here, because we do not care about the rest of this algebra manipulation. What I care here is what makes this thing undefined, and that's when the denominator is 0. What makes it equal to 0, that's when the numerator is 0. And so, yeah, we would have to go through this to find the 0, but to find the undefined piece, we have it already. It's right here. And so this algebra is more old school, and sometimes you see that where in Calculus 1, professors will make their students actually go through all of this to get this nice, simple, rational function. But typically we're stopping up here, we're substituting numbers up in here and everything, because that's enough to get us where we need to go without wasting time doing this. So that's it. Hope you're having a great day.